Part 2, y equals log to the base a of x. Alright, so this one is a little simpler to understand than the last one. So when we have y equals log to the base a of x, you'll recall also from last year that when you had like y equals log to the base 5 of, I don't know, 14, y equals log to the base 5 of 14, we learned last year how to find on our calculator logs of other bases. Our calculators would do base 10, which was a common log log, and base e, which was the natural log ln. But your calculator didn't have a button for log base 5, so we learned an equivalent expression, and that was we could do log 14 over log 5. I don't know if you recall that, but for our memory aid, I said, well, 14 is high and 5 is low, and it showed up in a similar position there. And that can also be ln of 14 over ln of 5. They will be the same answer. So we're going to apply that principle before we find the derivative to this one. So I'm going to have, let me move that up. We're going to have y equals log the base a of x, using the principle I just stated, can be rewritten as ln of x over ln of a. So using the very same principle I used over here with the log the base 5 of 14, ln of x over ln of a. These are equivalent statements. But I should be able to find the derivative of that, because this can be rewritten as 1 over ln of a ln of x. 1 over ln of a times ln of x. This is just the constant. So what's the derivative of ln of x? Well, we already learned that the derivative is going to be 1 over x, and then this constant will be in front. So we have 1 over ln of a, 1 over x. The derivative of ln of x is 1 over x. So 1 over ln of a is just the constant that follows in front. So constant, and then 1 over x we learned already. So therefore, we have, I'll just simplify that and make sure I'm on the right path. Alright, I am. I'm just going to simplify that, and that equals 1 over ln of a x. So, putting that together, we can say when y equals log to any base a of x, y prime equals 1 over ln of a, 1 over ln of a times x. So that's that rule. And then the second, we can generalize by saying y equals ln log the base a of u. So that's an expression in x. So it's going to be similar. We're going to get y prime equals 1 over ln of a and times 1 over u. So I'll put u here instead of x, followed by this derivative chain rule, du dx. Alright, so that's all the theory that you will need. Look how similar this turned out to just what we learned previously. When y equals ln of x, we had y prime equals 1 over x. So over here, when we changed it to log, a different base, not ln anymore, not base e, we still have that 1 over x happening, just like we did here, but you just tag on a 1 over ln of the new base, ln of a. All right, and then when we switch to u, very similar, always followed by the derivative of u. All right, hopefully you can put that to practice with gusto tomorrow. All right, sorry this will be getting up a little late after I get back from the airport. It could be 6 or 7 tonight. So there's my, I'm doing this at my grandson's house, so that's all I could find to write on. All right, well, I'll talk to you tomorrow. Over and out.